This video will begin Unit 2 on means and medians, measures of center. You should have the notes I provided you today in class. You may or may not need extra paper, so please get that at this time. A couple of definitions to get us started with. Parameter is a fixed value about a population. And remember, the population is the entire collection of data that we're talking about. And typically populations are unknown because it's hard to get data for every single value that may exist, which is why we use samples. But parameters are for populations, and you can remember that because parameter starts with a P, and so does population. Next we have a statistic, which is a value that is calculated from the sample. So we take that population, we take a sample of the population, which is a portion of it, representative of the entire population, and we can calculate statistics from that. So again, you can remember this because statistics starts with S, as does sample. Alright, we're going to talk about three measures of central tendency. That's the center of the distributions. The first of which is the mean. And the median, The median is the middle of the data, also referred to as the 50th percentile, which means remember that 50% of the data fall below the median and 50% of the data fall above the median. You should be very familiar with it because you've used it for many years. Observations must be in numerical order before you find the median, and it's the middle single value if we have an odd number of data, and just represents how many data values we have. But if we have an even number of data, it's the average of the two in the middle. The next measure of central tendency is the mean, which is the average. We use the Greek letter mu, which looks like a little u, to represent a population mean, and we use this letter x bar to represent a sample mean. And you're going to need to know those. We'll be using those throughout the year as we study statistics. And then this formula down here is just how you calculate the mean, which you should know how to calculate an average, but this is the statistical way to write it. It says that the sample mean, x bar, is equal to the summation of all of our data values divided by the number of data values that we have. So again, this uppercase E looking thing is called, it's a capital sigma in Greek, and it just stands for summation, and it means to add everything up that's behind it, which in this case behind it is x, which just means every data value that you have. So if my data set is 1, 2, and 3, I would add 1, 2, and 3, and then divide by 3 because there are 3 numbers in that data set. So you need to be familiar with what this formula looks like. The third measure of central tendency is mode. It's the observation that occurs most often, and you can have more than one mode if you have more than one number that occurs the same amount of times, or you can have no mode at all. We do not use it as often in statistics as mean and median. We will use the mean or the median to report centers of distributions. So here's our first example. Suppose we are interested in the number of lollipops that are bought at a certain store. A sample of 5 customers buys the following number of lollipops, and it's asking us to find the median, which is, again, the middle number. So I look at my data set. It's already in order from left to right, which is what I want, and there are an odd number of data, which means it will just be the center value. So marking off 1 from each side, I end up with a median of 4 lollipops, and I do want to identify what we're talking about in the context of the problem. In this next example, we want to find the median with 6, And now we have 6 data values, which means we have 2 in the center. They're already in order for us numerically. So these 2, we take the average of 4 plus 6 divided by 2, which is 5 lollipops. And now we're going to use that same data set and find the mean with those. So all we have to do is add our numbers all together, the summation of them, and divide by the amount that we have, which is 1, 2, 3, 4, 5, 6. When we add and then divide, we come up with a mean, so I'm going to use X bar, of 5.833 lollipops. And generally in statistics, we will always round to 3 decimal places, so please be in practice of doing that. Now, there are some things we can do in the calculator to quickly find the mean and the median from a data set. And I'm going to be showing you those in class, but I would like you to write down the steps now. You should have some paper space at the bottom right hand side of your paper of the note handout that I gave you in class. So if you please write these steps, and then I will show you further in class tomorrow. So first you'll press second and stat, which takes you to the list in your calculator. And in that list you should see list 1, list 2, and list 3. And so we are going to edit list 1. So after we push second stat, we'll press enter to edit list 1. Once all your data values are listed in L1, we will press the stat key and arrow over to calculate. From the calculate menu, we will choose number 1, which stands for one variable statistics. And this will come up on your home screen. Your calculator defaults to find the one variable statistics from list 1, so there's no need to type list 1 there. All you will have to do is press enter. And so again, in class tomorrow, we will use these steps to find some means and medians and different things. Alright, now we should be back on the left-hand side of your paper. And this is talking about the same lollipops, but they've changed the 12 to a 20. And we want to see how this affects our median and our mean. So if I change this change the 12 to the 20, and then I recalculate my median will still be 5, but my mean will change to 7.17. So the median was not affected when I changed this number, but the mean was affected. And now here again, instead of 20, we've changed this number to 50, a larger number. And recalculating the median and the mean, the median, again, remains as 5, and the mean changes to 12.17. So each time the median stayed the same, but the mean changed if I changed a data value significantly. So what the 2 previous slides have told us is something about the definition of resistant. So we've seen that statistics that are not affected by outliers are said to be resistant. And so in our 2 previous examples, we saw that the median was the one not affected by outliers. Remember, outliers are just values that are far away from most of your data, either smaller than or bigger than your majority of your data. And so we saw that the median is the one that is resistant and not the mean. And this is a reason why when our data is skewed either to the right or to the left, we will report the median as the center of our data and not the mean. And so that concludes our video for tonight. The right hand side of your note paper we will take care of in class tomorrow, and I'll see you then.